Good morning. I'm Jillian King-Cargile, and I use STEM Read Director, and I'm here at Argonne National Laboratory. What goes on here? A lot of science. It looks like we're broadcasting to some of our viewers, and other of our viewers might be having technical difficulties, but if you're just joining us, we are live at Argonne National Laboratory, where we'll be talking with Forrest Jellick. Thanks for being here today, Forrest.
Hey, thanks for having me. It's great to be here.
So let's just start right in. Could you give us a little bit of information about green racing?
Green racing. So green racing was a project that we had here years ago where we were taking a look at the effects that renewable fuels could have on vehicle sustainability and improving the environment and so forth. So we took a car and demonstrated that frankly, using the right fuels, you could not only increase performance, but you could really remove a race car from the environmental debate with regards to CO2 emissions and sustainability. So it was pretty awesome.
Well, great. And so for those of you watching at home, if you have questions for Forrest anytime during the webinar, you can ask them in the Q&A bar, or you can go to the event page and ask them. So Forrest, we're talking about Fuzzy Mud today by Louis Sachar.
Yeah.
So students have asked, is Biolean real, or could something like that actually exist?
Well, fortunately, Biolean is not real. It would be pretty scary if it was, going after the oxygen and so forth and growing. However, there's a whole myriad of alternative fuels that scientists and engineers and researchers are looking at. So everything from cellulosic ethanol to other forms of alcohol that actually come from natural substances, and that's a pretty exciting field. I mean, they are looking at using different biological processes to actually make fuels that can be sustainable in the long run. So it's pretty exciting. But fortunately, we don't have any of the side effects that the fuel in the book talked about.
Okay, so what kind of things are being done with alternative fuels? I think we think a lot about cars, but are there other applications as well?
Well, particularly the field that I work in, we really just look at energy with regards to cars and the fuels that fuel them. So I'm sure there's been discussions using renewable fuels even for things such as rockets, using, believe it or not, hydrogen peroxide as a fuel to fuel rockets, which is kind of fascinating. But particularly my expertise would center around what they're using for vehicle consumption. In the United States, it's pretty amazing. On any given day, we consume about 20 million barrels of oil. And 70% of that's for transportation. And to put that in perspective, a barrel of oil, if you were to take a 50-gallon drum and put it on the coast of California and stack them in a line, one day's consumption would stretch from California to Washington, D.C., back to California, turn around, and end up somewhere in the fields of Nebraska. I mean, that's how much we consume every day. So looking at alternative and renewable sources is critically important.
Okay, so tell us where you are right now.
I'm actually in the research lab. One of two labs I use. It's called the Advanced Powertrain Research Facility. And what we are looking at here, actually, we're doing tests this morning. It's a facility in which we test vehicles and take a look at energy flows. That's what we're interested in, looking at whole vehicle system analysis, efficiencies of components, different alternative fuels, and so forth. And I think the best way to describe it would be it's a treadmill for cars, where we can actually put a car in a lab setting, highly instrument it, drive it over any drive cycle we want, and measure energy flows, fuel consumption. If it's a battery vehicle, we'll look at battery consumption or component efficiencies. Or if it's an alternative fuel powered by hydrogen or ethanol or anything like that, we'll look at that too. So that's where I'm at.
Great. And can we take a look into the work area?
Absolutely. Go ahead and take a peek. We're running some tests right now before we're taking a look at energy flows and so forth. So I don't know if you guys have it up on the screen yet. Can the viewers see? I'm actually...
Yes.
Is it great? So what we're looking at is a vehicle actually running what we call a drive trace, and it's running over a standard speed cycle. And we've taken this vehicle and we've highly instrumented it, where we can take a look at fuel consumption, efficiency of the engine, the transmission, the wheel assemblies, pretty much everything that we want to look at this vehicle. And that's our fearless test driver and research assistant, Zach. He's actually, you see the wheel spinning there. He's actually driving a speed profile. And he'll be in there. That particular test he's running is, I believe, about 20 minutes. and then we'll collect emissions data, energy data, uh, analyze that stuff, and then go ahead and write reports, or make, depending on the project, make some of that available to the public and so forth. So, yep, we currently have a test going on, and that's what's happening.
Okay, and one of the things I noticed back there is a temperature gauge on the wall. So why does it matter what the temperature is in there?
That's a great question. So, if you were to take a vehicle, let's just say the vehicle that we were testing in there, and you were to go ahead and drive the exact same trace every day, the same, you're going from school to home and back, or vice versa, and you're going the same speed, same stops, and everything, you would find that the thermal effects have a marked impact on efficiency of the components, whether it's the engine, the transmission, the wheels, the wheel assemblies. And so our test cell, we actually have the capability of going below freezing and going very, very hot, and also simulating solar loads, so that we can start taking a look at those effects on vehicle efficiency and component operation and so forth. So it was keen that you picked up on it. Right now we're just running at ambient conditions, but there's been days in the middle of summer where it's below freezing in the test cell, which is pretty interesting to come in from a hot day in Chicago and walk into the cold test cell. Or conversely, in the middle of winter, we've had it near 100 degrees and high humidity in the test cell, and that's always nice to escape the cold in Chicago. In the test
Do you
cell.
go in there to warm up?
I have. True story. I have. On hot days, I've gone and warmed my bones in the middle of January and February before, so that's happened. Yeah.
We have a question from one of our school groups, and they're
Great.
wondering what kind of alternative fuels you might be testing in there today.
Today, I can't tell you anything about the vehicle, but I can tell you that this is, we're just running standard gasoline today, and we have a very specific, believe it or not, the type of gasoline that you run during the season will change, and so we run a very specific repeatable fuel on all our vehicles, so we don't bias the results. But today, unfortunately, I can't tell you that we're running anything exciting other than a standard fuel.
Okay, what's the most exciting fuel you've run then?
Ooh, exciting fuels. I get excited by them all. I particularly do take an interest in, traditionally from my background, I did like renewable fuels, so high concentrations of renewable alcohols. You've heard of ethanol. We've taken a look at ethanol from what we call cellulosic matter, or switchgrass. It comes from non-feedstock, and I've with the green racing program and some of the testing we've done, that's a fuel that I've taken interest in. But also, I think what I've really become fascinated and looked at more is a lot of electricity. So, as I'm sure some of the viewers here have heard of plug-in hybrids or EVs, something like the Tesla Model S, which is a battery electric vehicle, or a BEV. I've taken a lot of interest in that, and we do a lot of that type of testing here. So, as we look to the future, as technology evolves with battery storage and high-power electronics and motors, you're going to see EVs, become more into the market, and that's something I'm really fascinated about.
Okay.
Great questions. Great questions.
So back to the idea of green racing. We hear that alternative fuels might not be as efficient, or, things like that. Can they go as fast?
Actually, I have to display some of those. I know there's a lot of stuff out there in the internet and you can read, but actually, in the case that we showed, we were using an 85% blend of ethanol, and the 15% remainder of that was a standard gasoline blend. Our ethanol came from renewable sources. We showed both on engine testing and in vehicles that actually it makes more power. It has a much higher octane rating, so if you have an engine and can take advantage of that, you can actually raise a compression ratio. These are technical terms with regards to engines, but you can do a lot of things to take advantage and they actually make more power. The only difference is that if you were to take a gallon of that fuel and measure the heat or energy content in it and compare it to a gallon of gasolines, simply because of the chemical composition of ethanol, it really, in that blend, only had about 80% of the energy per gallon the gasoline did. So what you would have to do is you would just have to put a larger gas tank in a vehicle to go the same range. But as far as making power, it can make more power. The energy density is lower just by the chemical composition, but you can compensate for that in some pretty simple means. So yeah, that's a great question.
Okay, and we have another question from students, and you talked about some of the different components of alternative fuels, like switchgrass and things like that. So battery powered. What else? What are some other types of materials that you could make fuel with?
A lot of stuff. So over the years, for example, and I'll just take a whole smorgasbord, if you will, of different approaches to fuels, but CTL, coal to liquid, there are processes, the Fischer-Tropsch process, where coal can actually be converted to fuel. There is the cellulosic ethanol route, where you can actually take natural matter, decaying matter, and actually convert that over. One of the fields that I'm really excited about is algae-based technology, where they're starting to take a look at biological processes to make alcohol, or actually straight lipids, which are fats, that can be converted into fuels. And that technology is amazing because there's a lot of other, both through computational efforts and through biological processes, where these means are getting more effective and are also renewable fuels. So that's another form. Hydrogen, you could actually split water and take the hydrogen from water. So it's a big, broad field and a lot of exciting work to do.
Okay. People are asking if Argonne has an auto racing team.
I wish, but we do not. We're a neutral research lab, and so we actually don't get involved in profitable ventures like racing or so forth. But on my free time, I do race with my friends. Has nothing to do with work. I've always been into cars since I was a kid, and I love to do it. But we don't have an auto racing team, and maybe in another lifetime I'll be an auto racer. But in this time I just do it for fun with my friends.
Okay, so you've always liked cars. When did you decide that you wanted to combine your love of cars with science and research?
For my story and my history, it actually began when I was a little child, and I think we have some slides there, and we can probably bring that up. But when I was a kid, my father and his best friend Herb Stockton, they raced model airplanes, control line model airplanes. When I was a kid, they used to absolutely scare the heck out of me, and so I think we have a picture of both Herb and my father, and back in the day when they raced, and when they were young pups, and then also as they got older together. And to me, these guys were my heroes. They just raced these very loud, screaming, hot planes that I was terrified by, but the fascination stuck. And so seeing those two together do that played a big influence in me that I didn't realize at the time, but later in life realized that started my fascination with technical things and engines and all that stuff. And that was really my start. And it's funny, you kind of go back and take a look at it. I guess I didn't have much of a chance. It was just there, and the fascination hit me, and I went with it. So I think looking back in your life, a lot of you will actually see the same kind of thing happen. So you'll look back and say, oh, that's where it began.
So what did you study then?
So I started in my path, actually, right out of high school. I ended up going to community college, and I was actually I took an auto tech program, and I wanted to actually build race engines, but at the same time I started taking math classes and so forth and got into science. So I ended up transferring to university and getting my undergrad degree in environmental engineering, but the program I had was really a chemical engineering program. I focused on air quality chemistry. And then I transferred to Wisconsin. That was in Southern California. Then I transferred to Wisconsin and got my graduate degree in mechanical engineering, focusing on engine research. So that was my path of education and where I went along.
Okay. When you were in junior high, did you see yourself becoming a scientist then?
Never. Never. I didn't. Actually, what did I want to do? Oh, junior high. I think I wanted to race motorcycles or fly airplanes, I think, is what I wanted to do. So I ended up becoming an engineer.
And here you are.
And here I am. Yeah, yep.
So we have another question from our students, and they want to know how many cars you have tested.
Fantastic question, and I could not count. On any given year, we might have a dozen cars come through here, or more. So the list is long, and actually, this might be of interest to students. If you Google or you go on the internet and you take a look at Argonne's Advanced Powertrain Research Facility, and furthermore, look at something called the Downloadable Dynamometer Database, D-Cubed. We have a bunch of test data available from the vehicles, some of the vehicles that we've tested, and you can actually go there and download and take a look at the data yourself. And so a lot of that's like fuel economy data, energy consumption data, and actually get a flavor for some of the vehicles we've looked at. So I encourage you in your free time to go ahead and take a look at that and poke around.
Do you want to say that again? D cubed stands for what?
D-Cubed, Downloadable Dynamometer Database. Yeah. We have an acronym for everything.
I like it. We can put that online after as well. We'll
Right.
link to that on STEMread.
Fantastic.
Okay. Um, any more questions?
I like the questions. The questions have been great. So if you're curious, don't be afraid to ask.
Let's see. Oh, we're getting another question about solar cars. Have you ever tested them, and how do they compare?
Great question. Solar cars we haven't tested, and as it stands right now, the solar cars that you may have heard about are very specialized, extremely lightweight, low energy consuming testbed vehicles right now. The reason being is that the energy density relative to solar technology isn't quite there yet to power, for example, a car that we would imagine driving today. Solar is playing a role, obviously, in renewable energy with regards to the energy grid in the United States. But as far as if you take a look at the power requirements for a vehicle today, it's just not there. A vehicle would have to be very reimagined, very light, very small, and clearly wouldn't work so well in the Chicago winter when there isn't as much sun. So there are some limitations, but perhaps if you live in Arizona or Southern California and you were able to reimagine a car being very small, then it might have a market. In my opinion, I think as the future moves forward and we look at these technologies, there's not going to be a silver bullet that's going to solve the issue and removing cars from the environmental debate, if you will. It's really going to be silver shotgun pellets. There's going to be a lot of solutions that the market is going to look at, and people might have different needs and different requirements, and there might be a whole different selection available for fuels that are used and approaches that are used that match what people need.
Okay. We were talking about fuzzy mud specifically. So as a scientist, what did you think about the book?
Frightening. I think one of the fascinating parts to it that obviously I don't imagine a world in which some fuel like that or renewable fuel excuse me would have that issue, but I think it brings up a very good point, and that's that excuse me, I have a little bit of a cold, that whenever you come with a new technology or a new approach to something, you really have to look at the unintended consequences of what you do, and that's a really important thing, and it's wonderful, believe it or not, in my field and other fields as well, because it creates an environment where you have to be really critically thinking and to really look at the whole thing. So in a car, for example, if we just take a look at the fuel it consumes and what it burns, you may say, okay, that's the total impact, but you really have to look at the upstream impacts as well. Excuse me. Again, apologies about that. But it makes you look at the whole field from what we call cradle to grave or well to wheels, so you can fully understand the impacts. And so I think the book kind of highlights on that in its own way. It was an unintended consequence of exactly what happened. Thank you so much. Of being able to look at that. And so I think that was a really important, interesting part to the book.
So do you think that science fiction informs research in some ways, or helps give scientists kind of a worst case scenario to deal with?
Science fiction to me is amazing because it's people really thinking what could happen, and I do think it does. It's funny if you go back and look at like the original Star Trek television shows a long time ago with Captain Kirk and so forth, and they had these little flip-up phones. Somebody imagined at some point that we would have phones that didn't have cords or cables, and it happened. And before science ever went in that direction and developed that technology, science fiction or people that were thinking about those things informed it. So I really do think that plays a big role in helping drive directions and thoughts. It's just a creativity of the human mind and thinking what could be from nothing, and you push hard enough and you work hard enough and you can get there.
Okay, so we're getting a lot more questions about your job. So how long have you been testing cars, and what do you like best about testing cars?
I've been testing. Oof, I've been in the professional field doing this type of work for um, 15 years. But I'd actually started working on motorcycles and rebuild, working around mechanics and motorcycles and engines and so forth when I was 12. I rebuilt my first motorcycle when I was 12. Um, and I couldn't afford a new motorcycle, saved up some money, was able to buy a used bike, and it needed work. And fortunately, I was around my father because he did what he did. I was able to learn to use tools, and that interest led me from car or motorcycles to classic cars to my professional engineering career. So 15 years plus. I guess it was in my blood from a long time ago.
Okay, and someone wants to know what the most dangerous part of your job is. So do you work with dangerous fuels or, you know, I don't know, do cars ever fly off of the, the testing site?
I wish I could say I had a James Bond job, but a lot of it is computer data analysis from the testing we do. And we have a lot of safety precautions that we take to make sure that our environment here is safe. So I will tell you the most dangerous part of my job is my off hours when I go race my junkyard cars with my buddies. And, we've caught cars on fire and we've crashed and yeah, we've done all kinds of stuff. So my job is very safe. And the off hours has nothing to do with my job. I take a lot more risk.
So what do you learn from, I guess, crashing cars outside of work and other failed experiments at work? Is there a value to failure?
Failure is everything. And that may sound like a strong statement, but the only reason I was never on the path to become a great student and an engineer and scientist. And I had a professor when I was, again, I wanted to build engines, and I had a professor fail me on a test. And he called me into his office. It was when I was in community college, and he said, Forrest, I believe that you can do all of this, but you're going to have to work hard. Because I hadn't been challenged before in my life. Frankly, high school was not that hard, and you didn't have to work that hard to get through it. And then finally, when I transferred to college, and it was hard, I had somebody challenge me, and that was a failure. And at that moment, I had asked myself, what am I going to do? Am I going to rise to the challenge or not? And what I learned from that point, and I've taken with me ever since, is that hard work and dedication and learning from failures is what gets you where you need to go. And that applies to a lot of things, not only in your personal life, but also if you're trying a new technology. If you're trying to look at something different, you have to be willing to fail and not look at that as a negative aspect to say, okay, that didn't work. Now, how do I be creative to get around it? And that's something in my life that I think has played an important role, and I hope does in your life too. Failure, I encourage it, because if you're not pushing hard enough, you're not going to fail. If you're pushing hard, you will fail, but eventually you'll get there if you continue. So, and I firmly believe that.
Okay, and another question from our students. Can scientists really invent new organisms, new living things like they did in Fuzzy Mud?
That's an awesome question, and I mentioned early the algae-based fuels. They're doing it right now. They are taking technology where they're trying to and this isn't the field I'm particularly. I'm not a bioengineer or so forth, but I do follow it because of what fuels and potentials can come out of that. And they are with computer technology and the ability to understand the genome of species and to be able to use like CRISPR as a technology where they can actually splice genes and change them. This technology to me is very exciting, and they are doing that right now. And as a matter of fact, some of you sitting here watching this, you may be the people that figure out the magic. You could be the one that figured out that technology and did make the magic fuel from a bio-based technology. That could happen. I hope you do.
Okay, and you probably get asked this a lot as a researcher of cars, but what kind of car do you drive?
I do. So I just recently this last year sold. I had a Volkswagen GTI that I sold. I live in the city. I like smaller cars, easy to get around. And I bought, a friend had crashed her Mini Cooper S, and she sold it to me for cheap, and I rebuilt it in 2 weeks, and I'm using that as my daily commuter. I did just sell a classic car this last year for an investment, and it was a 1970 Plymouth Barracuda, and I'm looking for my next toy. I'm saving up now what my next toy is going to be. So my daily driver right now is a Mini Cooper S. Not too exciting, but it's fun. And I'm saving up for something that will be a little more exciting. So if we do this interview from a year from now, I'll probably have something much more exciting to talk about.
So do you change cars a lot then?
I do. I do. Yes, I've owned many brands and different types. Yeah.
Okay. Is there a dream car that you have?
Dream cars, plural. Yeah. Yeah. There is. If I could pick one car in all the history, it was the first car that got me excited about cars. It's a classic. It would be a triple black, black on black, 1970 Plymouth Hemi Cuda. Those cars now are multi-million-dollar cars. Very few made. Um, Maybe not multi-millions, but far beyond my pay scale. That would be a dream car. Um, I would also, gosh, we'll leave it at that. I would ramble on. We could talk an hour just about favorite cars. So that would be the creme de la creme for me. But there's a number past that.
Okay. And one more question that we had was, so you work with cars a lot, and that seems like a very male-centric, I guess, job. Are there women that work in your lab as well?
Oh yeah, there are, and not as many. I was actually chatting with somebody about that this morning. It was kind of interesting. In my career, I found that whether it was at college or even my professional career, that some of the best engineers I've been around have been women. So not as many women seem to go into the sciences, which to me is kind of a shame because as far as performance-wise, there's no difference. It's an equal playing field. Uh, and like I said, some of my best experiences and most talented people around were women. So we do have some here, just not as many. And hopefully that in the future, more women will consider going into the technical fields because clearly they have an amazing amount to contribute. So, come on board.
Okay, and we're about out of time, but could you sum up for us why you think it's important to study alternative fuels and to do the research that you're doing here today?
Absolutely. If we go back and take a look at the history of mankind, the 20th century, the growth of the 20th century has never happened at any point in history, and it's been stunning. And what powered that actually was fuel, energy, particularly petroleum. And it's been amazing what it's done. It's brought billions of people out of poverty around the world, and that's an amazing statistic. But obviously, petroleum is eventually going to get, we keep consuming it the way we do. It'll never run out because it'll just get too expensive to fully deplete. So we're going to have to find alternatives that match that so that we can continue the progress of standard of living for people around the world, but is also sustainable with regards to both consumption and with regards to the environment. So I think it's probably one of the most critical issues to address in our lifetime so that our children and our children's children can have the same or better lifestyle that we did, but also have the same advantages and as we move forward. So that I think would summarize why I think it's so important.
Okay, well, thank you, Forrest, so much for your time and expertise today. We're
Thanks.
really excited to be here at Argonne, learning from you and hearing about all your experiences.
No, I appreciate it. Thanks for stopping by and come by anytime. So take care and good luck, folks. Be well.